Okay, students. Well, it's chapter 4. This is a chapter on measurement and data analysis. And if you read this chapter and you thought to yourself, oh my gosh, or worse, I think you're in good company because this is the point where things get real, as they say. So, this video is going to talk through some what I call bottleneck concepts, where learning gets stuck sometimes. And so I'm going to talk about some things and try to clarify them for you as you move through the week. Okay, so the challenge here is going to be for me not to go too long in talking about this. I try not to make these lectures. I try to make them complementary to what you've already learned. I'm trying not to talk about things that are easy, but things that are challenging or bottleneck concepts or ideas. Um, okay, really quickly before I get going, understanding experiments is as much about, well, and understanding research, experiments specifically, but understanding research is as much about learning how to think critically as it is understanding the actual research methods. Let me say that again in a different way. You may never go on to do any research, at least not any like experimental research. Most of you won't, but you will end up reading research from time to time, and you will end up doing probably qualitative research in many of your jobs. So the really intense research that we're going to talk about this quarter, not so much. The other stuff, a lot. And the skills that you are gaining through this by learning about research methods are analytic skills, critical thinking skills, statistical literacy skills. And it's hard, and learning is hard. And people have this idea when they get into college and challenging classes that learning is easy. I should just get it. No, that's not how cognitive psychology and educational psychology depicts research from a scientific perspective. Um, depicts learning from a scientific perspective. It's challenging. It's hard. If we're not feeling that, we are probably not learning. Okay, and the easiest ways through, which are like the cramming, just to get the right answer, those don't stick. What does stick is spaced practice or distributed practice of your learning. That's why I construct this course in the way I do, with multiple exposures over time. Okay, and uh, self-testing. So those are two gold star standards for learning, and I just need to put that out there so that you can change your expectations if they don't line up. Finally, everybody can learn this stuff. If you're feeling at all discouraged, you need to change your mindset. There's a great body of work, of research on how your mindset about your ability to learn something will affect the outcome of that. Those with a fixed mindset tend to not do very well. Those with a growth and flexible mindset, optimistic about what they can do if they put the hard work into it, they tend to do okay. All right. So we're going to have a couple of these talks during the quarter, by the way. And I wish I could do it with you in person, but I can't. So please, I hope that somebody out there heard that and they're feeling like I'm normal. There are many people in this class who are struggling right now. Actually, I'd love if you went into ask questions here and you just said, I don't care. Use expletives. I don't care. Wow, this is crazy. This is hard. I feel like I got 10% of it the first time I read it. Okay, that's fine. Let's get some social support going on here. I just want you to feel normal. The normal thing is not to read chapter 4 and say, I'm good, got it all. Okay, so let's go. First of all, you got to know what a construct is. If you don't by this point, you're behind. If you couldn't explain a construct to somebody who lives in your household with you or a friend, then you are behind. What's a construct? Pause the video maybe and just answer that out loud for yourself. Seriously, pause the video and do it. If you can't, that's retrieval practice. It shows you that you don't know it. You need to go back and learn it. Okay. At this point, we are learning. We're scaffolding the learning. So what you don't get in previous chapters, you don't get. And then other things will be unstable as we scaffold up. Okay. All right. So operational definitions. There's a table in 4.1 that shows what operational definitions are. If you don't know how to do those well, if you didn't get 20 out of 20 on last week's assignment, you need to get 20 out of 20 on last week's assignment. I mean, you need to master this stuff or else you're going to lose points over it. So time to dig in and learn operational definitions. Reach out if you need help. Research examples come up now in the textbook over and over again, every single chapter. I love these because they are real research studies. They help put the theory and what they're talking about into real life. They show how to do this. Love these. Learn from these. Read them once, read them twice if you didn't get it the first time. Start to pull elements out of this. This was the independent variable. By the way, we'll be talking a lot about independent variables and dependent variables in the next coming chapter, but this is the independent variable. This is the dependent variable. This is the construct they're measuring. This is the operational definition. This is the hypothesis. This is the scale of measurement of the dependent variable. By the way, all these things will roll off your tongue as we get going. But for now, every time you see one, pull out all those elements. Just get the practice in and you will do very well in this course. Okay, research example number 2. This is an interesting operational definition, how they talked about preferential learning or looking, preferential looking. There's a lot of body of evidence that says when infants are uninterested in something, they look away. And if they're interested, they will pay close attention. It's called habituation. They're ready to see new things in the world. It's actually not unlike our consciousness, which pays attention to things that are new or novel, not things that are mundane or normal. So we see this behavior in babies. And so the whole thing was, if you see a ball traveling uphill and accelerating, do you know that's weird? And if you do, and you're a baby, you're going to do this. Huh? Okay. So they operationally define preferential looking in terms of, or I think it was looking away now that I think about it, but in terms of 2 seconds looking away. Okay. That's the operational definition. That's why we can use it. But it's not about the 2 seconds, is it? It's about, did they look away or not? And by the way, that's a nominal scale. Did they look away or did they not look away? You should, if that didn't make sense to you, why that is confusing, 2 seconds looking away is a nominal scale. You should pause right now and think through that, do some work thinking through that, because that could get a little complicated. Okay. So the next part of this chapter talks about reliability and validity. Every good psychological test has to be 3 things, okay? Reliable and valid and tested on a large sample. And there's a word that means tested on a large sample, but it's escaping me right now. Anyway, tested on a large sample, okay? Let's talk about these. There's a nice quote. Nope, maybe it was a note I made to myself on page 118. Okay. Remember here that we are talking about, forget that quote. We're talking about measurement here. Measurement. How do you measure a construct? That's what this chapter is about. So when we talk about validity here and reliability, we're talking about measurement. Okay. Later on, we're going to talk about whether a study is valid, whether a study is reliable. For now, we're talking about, is the measure reliable or valid? Now, we measure constructs or performance, right? Mental, like things that are inside constructs, or behaviors or mental performance or something like that, okay? Which would be more dependent variable. But in any case, we measure variables, right? We measure variables, and in psychology, those variables are often constructs. Okay, so here's what reliability is. Well, I think we have to back up. We need to know if we are claiming to measure, as we have previously, measure hunger, then last chapter we just came up with operational definitions kind of off the top of our head. What could be an operational definition for hunger? That was good enough for them. I mean, it was kind of common sense, right? But if you actually wanted to measure a construct, you would go into the research, or what we call the literature. Sometimes you go into all the research and you would figure out, is this a good way to study this? Um, is this a good measure to study this contract and construct? And the measure needs to be three things in order to be considered good. Say it with me: reliable, valid, and tested on a large population. Okay. So, again, the reliability of a measure is reliability kind of means repeatability. Okay. It means that once we get one score, if we do it again, we get a similar score, the same score on it. It produces reliable, repeatable, or repeated results. Okay. Now, there's lots of different ways to get reliability on a measure. We could test it, and this is maybe more details. Maybe I shouldn't talk about this, but I'll just say one way just to make the point. Okay. Reliability could be a person takes the same measure twice and scores the same 2 times on it. That would indicate reliability. Okay. Then we have what if you and I are both observing somebody's behavior in public and we have an operational definition or measure, okay, where you and I agree on how many times a person touches their face, okay? That's the measure. Is it reliable? Well, it would be reliable if you and I and whoever else came up with the same amount of touches. Reliable, okay? And that's called inter-rater reliability, where we're both rating behaviors and there is agreement. So reliability, it's agreement, it's repeatability. Does that make sense? And it has to do with measurement, okay? If I created a measurement for happiness and it was how many times you touched your face, that might be reliable, okay? But that might not be about happiness. This is validity, all right? Validity means that you are measuring what you intend or what you say you're measuring. Okay, just think about that example for a second. If I said to you, we're going to measure how many times people touch their face, and we agree on how many times a person touched their face, and I say to you, yeah, okay, well, that person is much happier than that person because they touched their face more. You'd say to me, wait a second, that doesn't seem like a valid measure of face touching. Okay. Now, there are 4 different kinds of validity, and your textbook talks about them, and they're a little bit confusing. And I am moderately concerned that you know them. I mean, you need to know them because you're going to have to answer questions about them. But are these really important at this stage of your education? Probably not. But they might make some sense to help you understand validity, which is super important overall. Okay. So under validity, there's 4 types. There's content validity. Content validity, it makes sense from a research perspective. So this face thing wouldn't have content validity because from a research perspective, face touching shouldn't have anything to do with happiness generally. Okay. So that's from a research perspective. Now, this is kind of close to face validity. Now, face validity is when you take a test online and it's a happiness inventory. And it seems like they're asking you questions about your mood, about how often you tend to smile in a day. That has face validity because it seems to the taker of it that it's a good test. Now, just because something has face validity does not mean it's a valid test, by the way. In fact, pseudoscience is really good at this. You will see all kinds of surveys in magazines and online, and most of these are not valid. They may claim all kinds of validity, but in fact, for a measure to become reliable and valid, it's really got to go through the ringer. I mean, It's years generally of testing. It's peer reviewed by other psychologists. You've got to make a case for why it lines up statistically with other measures. And that brings us to criterion validity. Criterion validity means that whatever our measure is, that it predicts. So scoring high on our measure predicts some other outcome. I think the easiest one off the top of my head, is that a high GPA might predict something about success in college. Although now that I'm saying that, I'm wondering if that's true. I know that's the claim. Okay, but let's say it is. Okay. So if I came up with another measure of I don't know, achievement in college, maybe it was something along the lines of like the more committed you are in college. So commitment, that this leads to better outcomes in sorry, I'm gonna go back. SATs, college. Okay, that's the connection I was trying to make. Now, if you were looking at something like commitment to your education and success, you would want to make sure, if this is a valid measure of commitment, that people who score higher on the valid measure of commitment do tend to do better. Now that increases your validity. Okay, sorry, that was a little clumsy. I hope you caught it. Okay. Construct validity. This is, I think this is the big one. Construct validity means our definition of, or our measure of this construct correlates highly to other known measures of this construct. Okay. So if I am going to measure somebody's if I want to measure some aspect of intelligence, my measurement of that better correlate to the WISC and the WAIS, which are famous kind of intelligence scales. And there's others, and we'd want to make sure that our scores, people who score high on our scores, they are on our measurement, they score high on those ones, and then I would have construct validity. Okay, moving on. Scales of measurement. This is one you should get. This is one that takes practice. This is one I've got a worksheet on Canvas, and you should be able to just, once you get it, go through those examples, and it's really clear cut once you get it. Okay. So nominal, ordinal, interval, ratio. I took French when I was small because I grew up in Canada, so I know that noir means black, and so noir is the acronym that I use for this, NOIR. Nominal is categories. They did or they didn't perform this behavior. They are or they aren't. It could be multiple categories. Which of these do you prefer? A hamburger or pizza or pasta, right? This would be a nominal category. All right, so ordinal is the next one. Ordinal is ranking. Okay, so when things are ranked, but they're not ranked in terms of any kind of equal spacing. Think about any kind of race where there's multiple people or animals. I'm thinking horse racing or something like that. First place could win by multiple seconds, and then second, third, and fourth could come really, really close together. But there would be no distinction when you're looking at when you're looking at a podium of gold medal, gold and silver and bronze. You don't have any idea of how far they were apart. You just know that there's a ranking there. So if there's ranking, it's ordinal. I'm going to come back to interval in a second because it's tricky. So let's come back there. The way I get to interval is by reasoning that it's not ratio. Okay. So ratio measures are, they're clearly numerical, and they have to do with like how accurate something is, how fast something is, how long it took, the weight of something. And here's where this doesn't make sense from an interval perspective for me, but textbook authors use it all the time. But it makes sense from a ratio perspective. It has a true zero. It has a true zero. You can get zero errors, and you could have a time of zero. And something could weigh 0. Okay, I'm going to contrast that now. And once you see examples, it'll make more sense. But I'm going to contrast that with interval. Okay. Interval doesn't have a true 0. So temperature would be interval. When you get to 0 degrees Fahrenheit, that doesn't mean temperature doesn't exist anymore. Okay. So temperature would be one that we would see sometimes. Okay. An interval scale. But where we most often see interval scales in psychology is what we call Likert scales, Likert, after the famous Dr. Likert, often called Likert incorrectly. So chalk that up. One for Cascadia College for teaching its psychology students how to say Likert correctly. Likert came up with this scale. These are interval scales, and you've done these before where they say, how engaged were you in your classroom on a scale from 1 to 7, with 1 being not engaged at all and 7 being very engaged? That's a Likert scale, okay? Notice there is no true 0 on that scale. There is, and you don't even need the numbers, really. I said they're helpful from a quantitative perspective, but you've also seen people go on a scale of 1 to 4, where 1 is none at all, and then 2 is slightly, and 3 is somewhat, and 4 is yes, a lot, or something like that. Okay. Those are interval scales. Anytime you see those kinds of choices and they're scaled with equal intervals between them. Okay. Oh, that's okay. That just came to my mind, but that's true. So rankings, remember, they don't have equal intervals. First place might have won by a lot. But intervals have equal intervals between them. Okay, so those are the 4 scales of measurement. The only way you get to know those is just by repetition, doing them again and again and again. Some of you will just get them right away. Others will have to work hard on them, and that's fine. So from now on, actually, in all of your homework, you are going to be, anytime a scale comes up, you will be expected to identify what kind of scale it is. Yep. And yeah, that'll be that. Oftentimes you actually have to tell me why you think the scale is that, because depending on how you interpret what the dependent variable is, and by the way, scales are usually for dependent variables, and you will need to tell me it is nominal because there are separate categories. It is ratio because they are measuring in weight, something like that. Okay. Here is the next major part of this chapter, and this is about descriptive and inferential statistics. I honestly think that this chapter should be measurement as a chapter, and then data analysis as a chapter, because we're about to get into data analysis. Let me flip my notes. Okay, I need to say a couple things before we start this. This stuff is tough. Your head was probably spinning unless you've taken a stats class before. As I said in our class meeting a week or two ago, I said, if you take research methods first, you feel behind on stats. If you take statistics, stats first, you feel behind on research methods. That's what the research says about these two courses. And so generally you take one before the other. Some institutions kind of put them in together. But generally, and by the way, sorry for the beeping. I don't know what's going on. Why am I? Yeah, everything's beeping. Anyway, I don't know whatever I was saying. Anyway, so if you felt a little lost here, it's because you haven't taken a stats class, but I also want to tell you it's been a long time since I've taken a stats class. I don't teach stats. I don't expect you to do stats in this class, but I do have to get you to understand what the difference is between descriptive research, inferential research, type 1 errors, type 2 errors, and null hypotheses and alternative hypotheses. Those are the big ones that you need to know. So I'm going to try to do my best to explain it to you, but you've got to get it. So if you need to rewatch this section a couple times to get it, or look elsewhere, maybe somebody does it better than I do, then please do that. Okay, so descriptive statistics describe the variable that you are measuring. So pretend you are a researcher and you are measuring people's a group of people's intelligence. Okay, say you're just doing descriptive research, like one variable, and you are measuring folks' intelligence. Now, that's a construct. Let me make this even simpler. Okay, this isn't really for psychology. I suppose it could be, but let's say you are measuring people's height. Okay, you are measuring people's height. Just give me a quick second right here. I'm going to get interrupted. I can just hear it coming. All right. Sorry about that. I probably won't even cut that out. But okay. So descriptive research describes the variable in question. Right now, we're talking about height. Let's say that we are going to measure height in inches. By the way, that is a ratio, nominal, ordinal, interval ratio. That is a ratio because we are measuring it in inches. And the great thing about about an operational definition of height, because you could have many operational definitions of height, but the one that we chose is height in inches, right? And that gives you a very nice data set afterwards, because we have this person over here who is 63 inches, and this person over here who is 70 inches, and this person over here is 65 inches, and so on and so forth. And then at the end of that, you have these 10 people, and you've collected these 10 numbers, or you've measured these 10 numbers on them. Those are, we know that's a valid and reliable measure of height, right? If you measure them again and again and again, it's not going to change. So that makes it reliable. We are pretty certain that inches are have been well established as a valid measure of height. So we got a valid, reliable measure, and now we have measured all these people. Now we can do some neat things, like we can do mean and median and mode with these measures of central tendency. So now I can look at what's the average height of this group. Okay, that's the mean. What's the median height of this group? That's the score in the middle from 1 and 10, and then 2 and 9, and then in order from, and I realize this is inverted, but median. And then mode, which one occurs most frequently? Those are really helpful in certain situations, like when you have an outlier. Sometimes that's kind of helpful. So if you had somebody who was like 7'7", that might cause the mean to go way up, then you would want to have a better way, and median and mode can get a better way to see what the average is. Okay, but there is more than that, right? There's more than mean, median, and mode. We can also look at the range. We can look at the lowest score or lowest measurement to the highest measurement. Now that's interesting, because if you had one group of 10 people with height, but you had that 7'7" person in there, maybe your range is something like 20 inches from the least to the from the least tall to the most tall is like 20 inches. Let's take a second group of 10 people and take their heights, and let's say that the range is only 8 inches. Now you know that the range for the larger group being 20 inches apart versus 8 is more varied. Okay, so it's more varied. It has more variance. It varies more. I hope, like VARIES, right? I always like to say, like, the 8-inch one is tighter. It's a tighter data set, and the other one varies more. So if you found a person there, you wouldn't if you just chose a person there, they would be probably farther away from the average height than in group B. Now, check this out. They could have the same median or mode. They could have the same average height in the group, But because there's so much range, you would know a whole lot more about the second group if you knew that the range was 8. Now, we call that the range, we call this variability, and range is the simplest way to tell how much variance is there within a group. First of all, are you hanging with me right now? If not, you might just want to go back a minute before I get into this next part. Okay. That's the range. Okay. The best way, a better way than range is really easy because you can just see very quickly what the range is from top to bottom. But a better way to understand variance is through standard deviation or variability. Standard deviation. Okay. What standard deviation does is it tells you the average distance each person is from the mean. The average number of inches in our case that each person is from the mean. Okay. Not any one person, but as a group, how distant is the average person from the mean? This gives us a way clearer idea of how variable our data set is. Okay, you got to hold that information now because we are going to now talk about inferential statistics. So descriptive statistics just are really simple. You measure it, it's right in front of you. You just measure what's there. That's descriptive. Okay. Inferential statistics is where psychology really shines, but it's all based on statistics, and you don't need to know it in this class, but you do need to know that it exists and why it exists. Okay. Whenever we do a study in research methods, we do I'm gonna shut off my phone. How's that sound? I didn't realize it was in my pocket. It just struck me. Okay. Whenever we do a study in psychology, we pull our human participants. I'll just talk about human participants right now. We pull our human participants from a larger sample of the population. Okay. And so know these words, use these words. The people in our study are the sample, and we pull our sample from the population. Okay. That's easy enough, right? Think about the ultimate population as humankind. Okay. The population of Earth. Okay. But we have this little sample of 20 people. Okay. And we're measuring their heights, and we put 10 people into group A and 10 people into group B. Are you with me? Okay. So, inferential statistics allow us to take the descriptive statistics that we've pulled from our sample. Now we've got the mean, median, mode, and we've got the variance of the sample of these two samples, right? What it allows us to do, and we're just going to pretend it's magic right now because we're not going to get into the statistics, okay? Yet. What it allows us to do is to look at those, apply some statistical analysis to them, and it tells us if it is likely that the differences between these two groups represents the population. It infers. Have you ever inferred something from someone? Somebody's telling you a story and you infer that they are upset about it. Okay. They didn't tell you they were upset. You inferred it from the data that you were receiving from them. Okay. This is what inferential statistics do. Inferential. You infer the truth of what you found in your sample for the general population. Okay. So, let's see. What else do I want to say about that? Okay. So, we will get into things called t-tests and ANOVAs, and there are tons of inferential statistics. There's a different inferential statistic for each and every type of research method. So it's the way that you generalize from the sample to the population. Okay. Because as psychologists, it doesn't matter what we learned in a little laboratory if it doesn't make any difference in the world. Remember that there's 4 goals of psychology: describe, predict, explain, and the final one is apply. And if this doesn't apply or better humans or better knowledge in any way, then what's the point of it, right? So this is why inferential statistics are so, so, so important. Now, if you didn't get that, you need to pause and go back and listen, or find somebody else who can explain it to you better, or ask me or whatever before you watch this next part, because the next part we are going to get into hypothesis testing. Okay. Hypothesis testing. This is confusing. I'm going to try to clear it up for you. Students struggle with this. I am telling you, this is what we're going to talk about when we're all together in class. Okay. All right. Here we go. So, when we start a study, oh, I've got to back up. I'm going to come back to the hypothesis testing. Okay. I got to go back to one thing I forgot to mention. From our descriptive study, we've got these two groups and we know the heights of both groups. We know the average heights of the groups and we also know the standard deviation of it. We know how much they vary. Okay. That is the essential information that you need to have for inferential statistic. I just forgot to say that part. You need inferential statistic is going to compare two or more groups generally in an experiment. Okay. And so for an experiment, in fact, a particular kind of experiment, you need to know that those scores. Anyway, I probably didn't need to go back and say that quite yet, but I did. All right. So we see a value of science here as we talk about null hypotheses. Okay. We see the value of science that we don't assume things. In fact, we make it very, very hard on ourselves. We talked about falsification a couple chapters ago. We don't assume that things are true. We assume that they're not true, and we try to prove their truth by falsifying them. Isn't that weird? Okay. So when you're doing a research question, let's say, does this new, let's say I have a new study technique for students for research methods, and I think that this study technique is going to help them score better on a midterm exam. Okay, so so I take all my students. In fact, I don't take my students. Let's do it even better than that. I randomly select students from a college population, and then I randomly assign those students into two groups. And by the way, you should know the difference between random selection and random assignment. Big, big, big difference. And you need to know that. Okay. So then I randomly assign them to two different groups. You with me? One group, they are going to study in any way they choose. Let's say I do three different groups. Any way they choose. The second group has some kind of traditional study techniques that we ask them to do. The third group, this brand new technique. All right. So now we set up an experiment. Okay. And, the dependent variable is going to be how they do on the midterm exam. Okay. So hopefully that's a good measure. Hopefully it is valid. Valid in this case would mean it's actually measuring what it says, which is knowledge about research methods. Reliable means that students would repeat their score, right? If they took it again, that it would be a good test because there would be a consistency to it. It's another word for reliability. Okay. The null hypothesis here is that there would be no difference between the groups. Now, I'm hoping that there's a difference between the groups. I've got this great study technique. Okay. It's wonderful. You should try it out. It's amazing. I'm really hoping it works. Why? In part so that I could publish on it. I'd like to write this study up, send it to a journal, a scholarly journal, and have them print it for me. And everybody will praise me, and I'll get lots of money. And my college will, it's just really great when you publish like that. So it's a little romantic, but that's kind of how it is. All right. So, but I start by saying the null hypothesis, I've got to remind myself that the null hypothesis is assumed that there's going to be no difference between these groups. And particularly, let's just talk about the group that I'm asking to study in a traditional way and the group I am asking to study in this new way. I'm going to say there's no difference between those. So I get these two groups, I have them do that. I am not expecting a difference. That's the default. Although there is an alternative hypothesis, and the alternative hypothesis says there will be a difference between them. This thing will work. The manipulation will work. Okay. So that's the two outcomes that can happen. Do you get it? either there will be a difference or there won't be a difference. And when we talk about that, we're talking inferential statistics. We're saying that there will be a difference when we apply an inferential statistic. There will be enough of a difference between these groups that we can assume that this is true for everyone. Okay, that's the goal of a good experiment. We want to assume that we hope to be able to assume that the differences we've got between the group are so what we call significant or statistically significant, because we're using operational definitions and numbers, right? So the differences are so significant that we can be sure, we never use that word, do we, in science, that we can be confident that this is a true thing that would work for everyone, or that applies to the whole population, from our sample to our population. Okay. So then I run the experiment, and then I find, oh my goodness, it did work. Look at this. This group scored way higher than that group. What else do we need to know? Standard deviations. Let's look at the standard deviations, the variation between within each group. Okay. And we learned, oh, they're very close. They're all, both at 4.3, whatever the scale we're using. Okay. Both at 4.3 or around 4.3. Okay, now, so we've got this big difference in their scores, and we've got the same standard deviation. We're thinking, this is great. We put it into the inferential statistics, a t-test calculation, and it says, yes, you can be quite confident that what you've manipulated here actually works for the general population. We think that you've got enough of a difference between these two groups that this is true out there. Okay. So then at that point, you reject the null hypothesis and you say, we reject that there is no difference, because in fact, we did find a difference, and we accept the alternative hypothesis that there was a difference. Okay. Are you with me? The other thing that can happen. So the one thing that can happen is we've got the difference. Fantastic. The other thing that can happen is that you don't find a difference between them. Okay. And that can be for a number of reasons, right? So let's say that they did, just on paper, they didn't score differently and they had a similar standard deviation and there's just no difference in the scores. So that's not going to turn out very well when you apply the inferential statistic with it. Also, if your new technique, they scored much higher, but the standard deviation was also much bigger. So it meant that there's lots of variation in the groups, which meant it worked for some people probably, but didn't for others. And so we've got these high scores, but we got these really average scores. The inferential statistic might say, no, that's not a clear enough difference between your two groups. So, okay. So then you, in fact, in that case, you accept the null hypothesis. There was no difference between these, and your dreams are crushed because you can't publish this. Well, you could, but probably a publisher is not going to pick it up. They only tend to pick up differences. That's leads to a whole other problems about ethics and bending the data and the research. So anyway, we'll maybe talk about that another time. But okay, we're almost done. We got to talk about type 1 and type 2 errors. So if you didn't get that last part, pause now, go back, listen, understand that in an experiment, you could have two outcomes. You can either have supporting where you are rejecting the null, or where you are accepting the null. Okay, where you are rejecting the null or accepting the null. Either there was a difference between the groups or the conditions, or there wasn't a difference between the groups or conditions. Okay, you with me? Here's what a type 1 error is. Just think about this. When the statistics are assuming that because of what you found in your descriptive research from your sample, okay, when the inferential statistic gets applied and says, yep, we can infer that this is true for the population, it's not certain. It's to a statistical confidence. It could always be the case that you have this wonderful outcome, but it was just your people. You had a sample that even was good and representative, but something happened in it where these people, for some reason, this group of people, they just happened to do well with your technique that one time. But if it was done again with a different set of people, uh, it wouldn't happen again. I mean, it wouldn't happen 10 out of 10 times again. You got lucky. Maybe that's the way to say it. You got lucky. In some ways you could say you got unlucky, but you got lucky. You found the change, the difference, but in fact it doesn't exist in the population. And there's been studies that have run into this where they did find this difference, and then they touted it as like this big finding, and then people start to replicate it and can't. And then we have to ask the questions, what happened? And that is a type 1 error, my friends. Okay. Type 1 error. I found a difference in my sample. The inferential statistic told me it's true. But in fact, once we apply that out to the population, it's not true. Nobody did anything wrong. It's just we fell into this, we did our best to infer whether this is true, and it said it was, but it wasn't. Okay. If you don't understand that, it's hard to score well on the questions that ask you about type 1 errors. Type 2 errors are just the opposite. Okay. Type 2 errors are when we didn't find a difference between the groups. So it looks like my learning technique did not work. And I'm crushed by it. I'm crushed by it. And the inferential statistic says, no, your differences aren't enough. It can't be inferred that the population is like this. Sorry, all this, your lifetime and career is over. Hopefully not that dramatic, but this is the heartbreaking one. That never makes it out of your laboratory. So you never learned that actually this was true in the population. You just had a weird group. You just had a group that you couldn't find it in. It's like if you ran this 10 more times, 10 out of 10 times, you would find that it worked, but you will never know, because once you figured out it doesn't work, you will probably never replicate that experiment on your own. And therefore, you will never know that it was a true thing. So that's a type 2 error. It's heartbreaking, right? Type 2 error is that there is a difference. My learning technique did work, but I didn't find it in my sample. And we will never know that it worked because it will never be applied to the population. Okay. This has been a long video. That was a long and demanding chapter. I agree with like 95% of what I said there. I think 95% of it was helpful, though it was a little long, but I think you might need it to be this week. So I hopefully we'll see you in class, and I wish you all the best as you work hard in your learning, as you ask questions, as you show up, as you connect with your peers and with me to make sure that you get what you're needing out of this course. Okay, take care.